Assalamu alaikum, dear cadets. Hope you all are well by the grace of Almighty Allah. In this time, corona pandemic are very alarming. So you must obey some rule. Wash your hands for 20 seconds. Use a tissue for cough and avoid touching your face. Due to coronavirus, our regular classes are not being held. But life will not stop. We must moving on. So that I am here to take your class virtually. Welcome to Borishal Cadet College online classes. I am Mohammad Kamaluddin Monir, lecturer in mathematics, Borishal Cadet College. Lesson introduction. Today I will take a lesson of class 8 subject mathematics and topic is circle. Your chapter 10. Learning outcome. After studying this lesson, cadets will be able to develop the concept of circle, explain the concept of pi, find the circumference and area of a circular region solving related problems, explain circle related theorem. Now dear cadets, what is circle? Using a pencil, compass and paper you can draw a circle in this way. The collection of all points in a plane which are at a fixed distance from a fixed point in the plane is called a circle. The fixed point is called the center of the circle and the fixed distance is called the radius of the circle.
Now, chord and arc of a circle. See this figure. In this figure, a circle is drawn with the center O. Taking any point P and Q on the circle, draw their joining line segment PQ. The line segment PQ is called a chord of the circle. The chord divides a circle into two parts. Taking two points Y and Z on two sides of the chord, and then we get two parts is PYQ and PZQ. Is part of a circle divided the chord is called an arc of circle, or in brief an arc. In this figure, two arcs are PYQ and PZQ are produced by the chord PQ. The joining line segment at any two points of a circle is the chord of the circle. Its chord divides a circle into two arcs. Now, diameter and circumference of a circle. See this figure. In this figure, AB is also a chord which passes through the center O. In that case, we call the chord a diameter of a circle. The length of a diameter is also called diameter. The arcs made by the diameter AB are equal. They are known as semicircle. Any chord that passes through the center is diameter. The diameter is the largest chord of the circle, and we'll prove later the diameter is the largest chord of a circle. Half of the diameter is the radius of a circle. Obviously, diameter is twice the radius. The complete length of the circle is called its circumference. That means starting from a point P, this point, the distance covered along the circle until you reach the point P is circumference. Now, first theorem. See this figure. Statement is the line segment joining the center of a circle to the midpoint of a chord other than diameter is perpendicular to the chord. Let AB be a chord other than diameter of a circle. ABC with center O and M be the midpoint of the chord. Join O, M. It is to be proved that the line segment OM is perpendicular to the chord AB. Our drawing is we have to join O, A and O, B. Proof. First step, in triangle OAM and triangle OBM, AM and BM are equal because M is the midpoint of AB. Also, OA equal to OB. Since radius of same circle and OM is common side, so that therefore triangle OAM and triangle OBM are congruent to each other, and we know if two triangles are congruent to each other, then every side of first triangle is equal to every side of second triangle. Also angles are equal, so angle OMA equal to angle OMB, angle OMA this angle and angle OMB this angle. Step second, since the two angles together make a straight angle and are equal, therefore angle OMA equal to angle OMB equal to one right angle. Therefore, OM is perpendicular to AB, and it is our required proof. Now, theorem 3, theorem 2, second theorem, and after that we will discuss theorem 3. Theorem 2 and theorem 3 are opposite. First of all, see this figure, this is a circle, and we have to prove that equal chords of a circle are equidistant from the center. If two chords are equal, they must be equidistant from the center. Let AB and CD be the two equal chords of circle with center O. It is to be proved that the chords AB and CD are equidistant from the center O. Drawing. Draw from O the perpendiculars OE and OF to the chords AB and CD respectively. Construction, we have to join O, A and O, C. Proof. First step, OE is perpendicular to AB and OF is perpendicular to CD. Therefore, AE and B are equal. Also, CF and DF are equal, since the perpendicular from the center bisects the chord. Therefore, this A equal to half AB and CF equal to half CD. Second step, given AB equal to CD. Therefore, A equal to CF. Now, third step. Now I'm in the right angle triangle OAE and right angle triangle OCF. Hypotenuse OA equal to hypotenuse OC because they are radius of same circle, and also AE and CF are equal from step 2. Therefore, triangle OAE and OCF are congruent. That is, OE and OF are equal, but OE and OF are the distances from O to the chords AB and CD respectively. Therefore, the chords AB and CD are equidistant from the center of the circle. Now, theorem 3. Statement is chords equidistant from the center of a circle are equal. See this figure. Let AB and CD be two chords of a circle with center O. OE and OF are the perpendiculars from O to the chords AB and CD respectively. Then OE and OF represent the distance from center to the chords AB and CD respectively. It is to be proved that if OE and OF are equal, AB and CD will be equal. That is, chords equidistant from the center of a circle are equal. If chords are equidistant, they must be equal. Drawing, we have to join O comma A and O comma C. Now, proof. First step, OE is perpendicular to AB and OF is perpendicular to CD. Therefore, angle OEA and angle OFC both are right angle, one right angle. Now, in right angle triangle OCF and OAE, in this two right angle triangle, hypotenuse OA equal to hypotenuse OC because they are radius of same circle, and OE and OF are equal supposition. Therefore, triangle OAE and triangle OCF are congruent. Therefore, AE and CF are equal. Third step, A equal to half AB and CF equal to half CD, since the perpendicular from the center bisects the chord. Using this theorem, we can write this. Now, half AB means AE and half CD means CF. Since AE and CF are equal, AE and CF are equal, therefore half AB and half CD are equal. Okay? That is, AB and CD are equal. And it is a record proof. I think, dear cadets, you all understand this theorem, this three theorem. Now, I'll go for exercise. Prove that diameter is the greatest chord of a circle. To prove this, we must know that in a triangle, sum of two sides are greater than the third side. First of all, see this figure. Proposition is, let O be the center of the circle ABCD. Let AB be the diameter because AB passes through the center O, and CD be the chord other than diameter of the circle. It is required to prove that AB is greater than CD. Our construction is OC and OD must be joined. Proof. Here OA equal to OB equal to OC equal to OD because they are radius of same circle ABCD. Now in triangle OCD, OC plus OD is greater than CD, and because we know the sum of two sides is greater than the third side, or replacing OC and OD by OA and OB, we can write OA plus OB is greater than CD, but OA and OB, the sum of OA and OB is AB, that is AB is greater than CD, and it is our record proof. So that we can say diameter is the greatest chord of a circle. Now exercise. First of all, see this figure. Prove that between the two chords, the larger one is nearer to the center than the smaller one. Suppose O is the center of the circle ABDC. AB and CD are two chords where AB is greater than CD. OE and OF are perpendiculars from center O to the chords AB and CD respectively. We have to show that OE is less than OF. That is, the getter chord or the larger chord is nearer to the center than the smaller one. That is, OE is smaller distances than OF. That is, OE is less than OF. It is our record proof. Construction: join O comma A and O comma C. Now proof. Since O is the center of the circle, O is perpendicular to AB, then we get A equal to half AB. Similarly, O is the center of the circle and OF is perpendicular to CD, then we get CF equal to half CD. Now, in the right angle triangle OAE, OA is hypotenuse. According to Pythagoras theorem, we can write OA square equal to OE square plus AE square. This is equation number 1. Again, in the right angle triangle OCF or OFC, OC is hypotenuse. Similarly, by Pythagoras theorem, we can write OC square equal to OF square plus CF square. This is equation number 3. But OA and OC are radius of same circle. Therefore, OA and OC are equal. Then from equation 1 and 2, we can write OE square plus AE square equal to OF square plus CF square. Now, changing side. AE square minus CF square equal to OF square minus OE square. But given AB is larger chord and CD is the smaller one, therefore half AB is greater than half CD. But half AB means AE and half CD means CF. Squaring both sides, AE square is greater than CF square, or AE square minus CF square greater than 0. Now replacing AE square minus CF square by OF square minus OE square, from 3 we write this, or OF square is greater than OE square. Now therefore OF is greater than OE, that is OE is less than OF. So we can say that the larger chord is nearer than the smaller chord. Now another exercise. A chord AB of one of two concentric circle intersect the other at C and D. Prove that S equal to BD. Using this figure. See this figure carefully. Let us suppose that O be the center of the circle, two circle. AFB the greater circle and C is the smaller one. O is the center of these two circle. It is required to prove that AC and BD are equal. Construction: draw OE perpendicular to AB. Now proof. First step: O is the center of circle, AFB the greater circle, and OE is perpendicular to AB. Therefore, A equal to B. And justification is the perpendicular from the center of the circle to a chord bisects the chord. Step 2, again O is the center of the circle CHD and O is perpendicular to CD. Therefore, CE and DE are equal. Same reason. From step 1 and step 2, we write AE minus CE equal to BE minus D. That is AE minus C equal to BE minus D. that is AE minus CE means AC and BE minus DE means BD, so that AC and BD are equal. It is our record proof. Now another exercise. Prove that the line joining the midpoints of two parallel chords passes through the center and is perpendicular to the two chords. See this figure. Let us suppose that ABCD is a circle with center O. N and M are middle points of the parallel chords AB and CD respectively. M and N are joined. It is required to prove that MN passes through the center and is perpendicular to the chords AB and CD. Construction, we have to join O, N and O, M. Proof. First step. O be the center of the circle and N is the middle point of the chord AB. Therefore, ON is perpendicular to AB. Justification is the line segment joining the center of the circle to the midpoint of the chord other than the diameter is perpendicular to the chord. Step 2, again, O be the center of the circle and M is the middle point of the chord CD. Therefore, OM is perpendicular to CD. Therefore, ON and OM are perpendicular from center O to the parallel chords AB and CD respectively. Therefore, MN passes through the center and is perpendicular to both chords AB and CD, and it's our record proof. Now, another exercise. Two chords AB and AC of circle make equal angle with the radius through A. We have to prove that AB and AC are equal. Let us suppose that O is the center of the circle ABC and AB and AC are two chords. O, A are joined. The two chords AB and AC has made equal angles with the radius OA through A. So, angle OAB and angle OAC are equal. It is required to prove that AB and AC are equal. Our construction, join O, B and O, C. Using this figure, we'll prove angle OBA and angle OCA equal this way. First step, in triangle OAB, OA and OB are equal because they are radius of same circle. Therefore, angle OBA, this angle OBA and angle OAB are equal because opposite angles of equal sides are equal. Again, in triangle OAC, OA and OC are equal. Similar way, therefore angle OCA, this angle, and angle OAC, this angle are equal. Region or justification, opposite angles of equal sides are equal. Now, angle OBA equal to OAC. Therefore, angle OBA and angle OCA are equal. Now, in triangle AOB and triangle AOC, OB and OC are equal. Angle OAB and angle OAC are equal. Angle OBA and angle OCA are equal. Therefore, triangle AOB and triangle AOC are congruent. Therefore, side AB and side AC are equal. It is our record proof. Now, it's time for homework. First question, prove that if two chords of a circle bisect each other, their point of intersection will be the center of the circle. Second question, a circle passes through the vertices of a right angle triangle so that the center lies on the midpoint of the hypotenuse. Dear cadets, if you have any query or any question, you can ask me through comment section. And the last, COVID-19. In this time, you must be aware of coronavirus. You know, coronavirus is very alarming in this time. So stay home and remain safe.